Hello students, welcome back. Now today we will discuss scattering of light and its application. So let's start. Student, let's deal with the scattering of light. Now see, when light from the sun enters the Earth's atmosphere, it gets spread in all possible directions. By whom? Dust particles, air molecules present in the atmosphere. This was first studied by Rayleigh. So he studied this part. Now, what is the effect of this scattering of light? Now, scattering is the process of absorption and then re-emission of light energy. So it is absorbed and re-emitted. But when size of air particle is smaller than the wavelength of the incident light, they absorb the energy of incident light and re-emit without changing its length. But scattering is not same for all wavelength of incident light. So how it changes? So wavelength of the incident light is the main factor. The intensity of scattered light is inversely proportional to the fourth power of wavelength of light. As the wavelength increases, intensity of scattered light decreases. And as this increases, intensity decreases. So what this indicates? Wavelength of violet light is least. So violet light is scattered most. Same way, when you just look at the another end of the visible light, that is the red light side, then wavelength of red light is most. So red light is scattered least. This thing you have to always keep in mind. But violet, indigo, blue, they scatter almost together. The resultant scattered light is always the blue one during the daytime. But when you just consider the and, violet is least, red is most. But when size of the air part molecule is bigger than the wavelength of incident light, then scattering of light for all wavelength of incident light is same. All color to the same extent. So the resultant light with no color. So it is always white. Now deal with the some applications of scattering of light. Now students, you might have observed during the sunrise and the sunset, that is the dawn and the dusk period, the atmosphere appear red. Color of the sun is also red. Why? Because at this time sun has to travel the longest distance of the atmosphere to reach the earth. Since blue color is scattered more, much of it is lost. While the red color is scattered a little, so it is not much lost. As a result, the sun and the region nearby it is seen red. Because of that, you feel that sun is also red and nearby atmosphere is also reddish. That is little bit orangish red. Now students, you have observed at noon the color of the sky is white. Why? Because sun is directly our overhead. Now the distance traveled by is less. Sun has to travel shortest distance. Because of this, whatever light we get, that reaches without much scattering of any particular color. So white light will remain white only. Because of that, the color of the sky is white at noon. Now student, whole day you observe that the color of the sky is blue. Why it is? Blue light due to its short wavelength is scattered more as compared to the red light of the long wavelength. I told violet, indigo, blue, they scattered together. So the scattered light is always the blue in color. Because of this, the light reaching our eye directly from the sun is rich in red color. Why? Because the red color has the long wavelength as compared to blue. But the light reaching our eye from other direction is scattered blue light. Because of this, when you just look around the sky, other than the direction of sun, the sky appear blue. Now students, black color of the sky in absence of atmosphere. Now you know that there is no atmosphere on the moon. So there will be no scattering of light. So no scattered light would reach our eyes. No scattering, no resultant color. So the color will be black. Because of that, the sky will appear black. So you have to keep in mind, in absence of atmosphere, no scattering, no color. Now, clouds are seen white. Why? Why clouds are seen white? Now see, there it is on the surface of the earth. There the dust particles and water molecules are bigger in size. And already we have done, when the light falls on the particles bigger than the wavelength of the visible light, so all colors scatter to almost same extent. So resultant will be no color. So the clouds are seen white. White light after scattering also appear white. Because of that, the clouds are seen white. Now students, why red color is used as a danger signal? Why? The wavelength of red light is longest, around it is 8000 angstrom unit. So the light of the red color scattered the least. Hence the light of the red color can penetrate to a longer distance without becoming weak. So it will remain in the atmosphere for more time. Thus red color can be seen from the farthest distance. Hence it is used for danger signal. So that can be visible even in the fog. So always keep in mind, the scattering of red color among the visible range is the least. Because of that, it can be seen from the farthest distance for longer time. Thanks for watching this video, students. Now hope you have understood the scattering of light and its application. Only what you have to keep in mind, then when there is no atmosphere, there is no scattering. So the atmosphere appears black. Okay. But when the dust particle size and air molecule size is bigger than the wavelength of incident light, then all the light scattered to the same extent. That's why white. Rest all I have explained in the application. Then also if you have any doubt, comment or mail. If you are new to the channel, share and subscribe.